What if the past wasn't truly buried? What if life from 100 million years ago could return? For decades, scientists dreamed of finding intact DNA from an ancient creature. Many believed it impossible. The forces of time, too destructive for such delicate molecules. But in a remote corner of the Arctic, a discovery was about to challenge everything.
The team searched for rare mineral deposits, not expecting to unearth a biological miracle.
We found it.
He instantly knew this was no ordinary find. Its unique composition hinted at something extraordinary. Look. The preservation, it's unbelievable. This isn't just amber. Extracting the Cretaceous mosquito was a delicate operation, requiring utmost precision.
Every vibration, every temperature change could compromise the precious contents.
The Cretaceous mosquito, a potential key to the past, began its long journey to the lab.
Back at the research facility, Dr. Lena Petrova awaited the arrival of the incredible specimen.
Her expertise in ancient biomolecules made her the ideal candidate to unlock its secrets.
The moment of transfer was charged with the weight of scientific history.
Inside, nestled within the ancient resin, lay their ultimate prize.
The Cretaceous mosquito, frozen in time, offered a window into a lost world.
First, a thorough examination of the amber matrix itself. What made this particular piece so special? This amber contained unique mineral inclusions, hinting at an anaerobic, deep earth burial.
Conditions that could have significantly retarded DNA degradation over millennia. The scientific team developed a novel, non-invasive extraction protocol.
Using a femtosecond laser, they began the painstaking process of isolating the Cretaceous mosquito.
Each pulse vaporized molecular layers without generating heat, preserving the internal structure. One wrong move, and millions of years of potential data could be lost forever.
The stakes were incredibly high. This was uncharted scientific territory.
Finally, after weeks of preparation, the moment of truth: DNA extraction.
Even the smallest contamination could invalidate the entire experiment.
Then, the waiting game began, as the sequencers worked tirelessly. Every passing hour felt like a century. Could it really be there? The data processing was immense, sifting through billions of base pairs for signs of integrity. Then, a flicker of recognition. A pattern emerging from the noise. She saw it. Not fragments, but long, coherent strands of ancient DNA.
We found it, Aris. We actually found it. Intact.
Unbelievable. 100 million years, and still viable.
This changes everything we thought we knew about DNA preservation.
Today, we announce a discovery that redefines the boundaries of paleontology and genetics.
We have successfully extracted viable ancient DNA from a 100-million-year-old Cretaceous mosquito.
This Cretaceous mosquito, encased in a unique amber matrix, holds genetic material previously thought impossible to recover.
The implications are profound. This isn't just a fossil. It's a genetic time capsule.
The potential to understand ancient ecosystems even to reverse extinction, is now on the horizon.
But with such power comes immense responsibility. The ethical questions are as vast as the scientific possibilities.
The Cretaceous mosquito, once a simple insect, now holds the key to humanity's most audacious dreams.
The discovery of the Cretaceous mosquito was just the beginning. The real work, the scientific quest, was about to commence.
Bringing the Cretaceous mosquito to the lab meant confronting unprecedented challenges in ancient DNA retrieval. For millions of years, this tiny insect held a secret, locked away in time, defying decay. Weddick, a true biological marvel.
Far beyond what we dared hope.
The challenge now, to extract viable DNA without damaging the fragile specimen.
Every step must be precise. One error could compromise everything.
There's no room for contamination.
The atmosphere in the lab was tense, filled with anticipation and the weight of scientific history.
Using a femtosecond laser, we could access the precise target area without damaging the surrounding fossil.
It's an incredibly delicate procedure. One wrong move.
Every microscopic fragment was a potential treasure chest of ancient genetic information.
This tiny sample holds the key. The next phase is purification and amplification.
The extraction process itself is a multi-stage purification, isolating DNA fragments from contaminants.
We're not just looking for DNA, we're looking for intact sequences, stable enough for analysis.
Advanced bioengineering techniques were employed to repair and reconstruct degraded genetic material.
The initial results were cautious, but undeniably promising. There was something there.
Eris, look at this. These bands indicate significant fragments.
Unbelievable. This is beyond anything we've seen in ancient samples.
The lab buzzed with a newfound energy. The impossible was slowly becoming plausible.
With enough material, the sequencing began, turning raw data into a readable genetic blueprint. Then, the first sequences emerged, patterns that hadn't been seen on Earth for millions of years.
We have it. Intact, readable sequences.
This isn't just a fossil. It's a living archive.
The implications were immediate and staggering. A window directly into the deep past through DNA.